When you look at a car, what do you really see? You probably notice the color, the brand, maybe the shape. But underneath all that shiny paint and metal, there's a skeleton. And that hidden structure, well, that's what truly defines what a vehicle is, what it can do, and where it's all headed. Okay, to really get this, we've got to start with something kinda nuts. This is the Lazarus LMV 496. On the road, it's a super powerful electric motorcycle. But then you flip a switch, 4 jet turbines spool up, and yeah, it actually flies. It's basically a real-life transformer, and its biggest secret is buried deep in its skeleton. I mean, it's incredible, right? But what in the world could a flying jet-powered motorcycle possibly have in common with your family sedan? Well, the answer is kind of surprising. It's pretty much everything, and it all comes back to that hidden skeleton. So here's the game plan for today. We're going to start with that hidden skeleton itself. Then we'll jump into the big shift from old-school ladders to modern unibodies. After that, we'll look at why we drive the cars we do, how personal transport is being totally rethought, and finally, what this transforming future might actually look like. All right, first things first, let's peel back the skin and see what's really going on under there. Okay, so here's the big idea. Every single vehicle, I don't care if it's a tiny scooter or that crazy flying bike, is built on a core structure, a chassis. This skeleton is the absolute foundation. It decides the vehicle's strength, its shape, and, its whole reason for being. It's the one thing that connects them all. Now, historically, this skeleton has really come in 2 main flavors. This is the story of the big switch from ladders to unibodies, the 2 designs that literally shape almost every car you see on the road today. So first up, you've got the granddaddy of them all, body on frame. This is the original way of doing things, where the vehicle is basically 2 separate pieces. You have this really heavy, rigid, ladder-shaped frame that holds the engine and all the running gear, and then you just plop the car's body on top. All the strength comes from that massive frame underneath. And then the revolution happened, the unibody. The whole philosophy here is completely different. The body and the frame are one single integrated structure. That outer skin isn't just there for looks, it's actually providing the strength, kind of like the shell of an egg. And this is what that looks like in the real world. You can see how all these different pieces of stamped metal are all welded together. They create this one single, strong, but also lightweight shell. This is the skeleton you'll find inside almost every car sold today. So which one's better? Well, it really depends on what you need it to do. The body on frame, it's a total brute. It's perfect for towing heavy stuff, which is why big trucks still use it. But it's super heavy, and that rigid frame isn't great at absorbing crash energy. Unibodies, though, they're the smart ones. They're lighter, which means better efficiency. They give you way more room inside, and they're a whole lot safer because the entire structure is designed to crumple up and absorb the force of an impact. But wait, there's a third option, kind of the special forces of car skeletons, this space frame. Just think of it like a 3D skeleton, this complex, beautiful cage of tubes. It's incredibly light, but also unbelievably rigid, and that is the secret sauce behind the razor-sharp handling of the fastest cars in the world. Okay, so we've got these different skeletons, but why does it matter? How does all this engineering stuff actually decide what you and I end up buying? Let's connect the dots between the engineering and what we want as consumers. All right, take a look at this number. 46%. Just let that sink in for a second. What on earth could that represent in the global car industry? That right there is the insane dominance of the SUV. Back in 2022, they made up nearly half of all vehicles sold across the entire planet. And what's driving it? Well, it's us. We demand space, we demand versatility, and that demand connects directly back to a vehicle's skeleton. And the Range Rover is a perfect case study here. It looks like one of those big, tough, old-school body-on-frame SUVs, right? But its secret is this super advanced all-aluminum unibody. This skeleton makes it way lighter and more efficient than older models while still giving it that huge, spacious interior that everybody wants. That's engineering meeting market demand right there. But what happens when the old rules just don't apply anymore? Well, that's what's happening right now. And it's leading to a complete rethink of what a vehicle even is. I mean, all of a sudden we're seeing this explosion of brand new ideas. We've got vehicles so narrow they can literally fit through a standard doorway. We've got all these personal transporters for zipping around the city. We've even got transforming robots that'll follow you around like a pet and then turn into a scooter when you need one. This is just a total reimagination of personal transport. So the big question is, what's making all this possible? What's the secret sauce? And you know what's crazy? The answer isn't actually the skeleton this time. It's the power source. By ditching a single huge, heavy engine and replacing it with flexible, modular batteries, designers were suddenly set free. It was like the handcuffs were off. They didn't have to build a car around this giant block of metal anymore. The battery could be part of the floor or the frame or anywhere, really. That freedom is what unlocked all these wild new shapes. And all this brings us right to our final thought. The future is transforming. So if the old body on frame gave way to the unibody, what's next on the menu? Well, it turns out the future isn't about picking just one design. It's about using the absolute best material for each specific job on the car. Take a look at the skeleton of this Audi A6. It's a multi-material masterpiece. You've got super strong steel right where you need it for safety, mixed with lightweight aluminum in other areas to save on weight. It's all about putting the right material in exactly the right place. And the results? They're pretty incredible. This hybrid approach shaved 30 kilograms. That's about 66 pounds off the car's skeleton. That's like telling a small passenger they can't ride with you anymore. Permanently. It's the ultimate optimization. You get all the strength you need for safety and all the lightness you want for efficiency. So, from simple wooden ladders on the very first cars to these intelligent, multi-material structures we see today, vehicle skeletons have been constantly changing for more than 100 years. They've adapted to our need for speed, for safety, and for space. But as our world keeps transforming, as our cities get denser and our tech gets smarter, the real question is, what will these skeletons need to become next?